Okay, so Unit 5, this unit, the thing you need to know, and I think I say this in the video, I think, but it bears repeating a few times. This unit, Chapter 5, is the most biology of anything in math, at least at this point. There is a lot of vocabulary in this lesson, a lot. And they're all really similar. You're gonna have to remember the difference between a circumcenter, an orthocenter, and bisectors, and altitudes, and medians, and whole bunches of stuff. There's like lots to memorize in this unit, and like lots and lots. Perpendicular bisectors, all of these things. And so, nobody ever listens to me on this, pretty much. But I'm going to tell you right now that you probably want to start making flashcards like today. And start like actually memorizing this stuff, because there's a lot of vocabulary and you have to know it, and you have to be able to keep it separate, and you have to be able to keep things that sound really similar separate. Does that make sense? It's not necessarily hard. Honestly, this unit isn't that bad. Most of the formulas, most of the math is pretty easy. You know, if you can punch 2/3 times something on your calculator, you can like do the math, right? The math is not very hard, like the algebra parts. And a lot of the properties are fairly straightforward. There's just a lot of vocabulary to keep separate. So not hard necessarily, just a lot to memorize, okay? So again, I know you're probably not gonna listen to me, and it doesn't change the fact that it's a good idea to go ahead and start making you some flashcards and studying them a little bit every day. Like take 5 minutes, 10 minutes, something, and start memorizing the different things, because you gotta know them. Make sense? Easy peasy? Make sense on the internet? Okay, great. So what numbers did we do? 10 through 30, that sounds accurate. Number 10 is 9. 12 is 10. 14 is 16. 16 is, you would draw out a thing and it would have some perpendicular bisectors, that it would be so cute. And if we need to look at it, we can. Number 18 is segment CF. Number 20 is segments DA and segment DB. 22 is 17. 24 is 4. 26 is 30. 28 is 13.1. And 30 is 28.5. What questions do we have?
Can we do 12?
Yeah. We can do 12. More or less that. And we're supposed to find the measure of GE, I think, yeah? EG is how they list it. Same segment, though. All right, so what do we have a picture of?
Two triangles.
Okay, so we have a picture of a big triangle, and then we have a segment. This one is actually drawn like this in the book, which is maybe a little easier to talk about. There he is. One of the long lost sheeps.
Is this only it?
Yep, Gene is off taking a test. Reese is out of town or sick or something. Probably, out of town. He's like doing a thing, whatever it's called, whatever. Natalie, I don't know. Gina's taking a test. Ashton, I don't know if I know. I probably do, but I don't remember. And somebody else. Ashton. It's just right there, usually, more or less, over there. Likes to make fun of Helen. Helen also, I don't know. I might know. I just don't remember if I do know. Okay, so back to the question. What do we have a picture of? We have a picture of a big triangle. We have a picture of a segment on there. What kind of segment is it, and how do we know what kind of segment it is? It is a perpendicular bisector, and we know that because of perpendicular and what else?
And the two sides are equal.
How do you know? That tells us that the whole triangle is an isosceles. That doesn't tell us that it's perpendicular bisector. Because I could slide this over and make it perpendicular, but not be a perpendicular bisector. But because it doesn't tell us in this, that tells us it's perpendicular, not that it's a perpendicular bisector. That's what I'm trying. Let me finish what I'm saying real quick. Because I could have a segment that's perpendicular over here, but that doesn't tell me it's a perpendicular bisector. What does? Right, we've been over this. Yes, the right angle, and what else? Because look, let me draw one in another color to show how useless y'all are being right now.
I didn't have a question on this problem either.
But now you do. You know I'm just like being funny. You're not being useless at all. Maybe I'm not being funny, but I'm trying to be funny. Okay, that line's perpendicular. It's not a perpendicular bisector. How do I know that that black one is a perpendicular bisector?
Because it is in between.
Where else does it cross?
At the vertex.
At the vertices?
Vertex is a singular, but yes. Yes, because it goes to the vertex and it's perpendicular, right? And if it goes, like if I drew a line that was perpendicular to this and went through here, it would be a bisector. Okay?
How do we know it's going exactly through there?
What?
How do we know it's going exactly?
Because the picture is better than what I drew on my board. And it has to be to make this problem work. If this was on a quiz or a test or something, well, a test specifically, it would probably say segment D or line D, whatever, there would be a point, is a perpendicular bisector, probably. That way there's no ambiguity. Or possibly that line crosses through point D, possibly, it would say something that would give you like some assurity that would be, or I would forget and then you'd be like, is this? And I'd be like, yes, it is, sorry. Yeah. But it is a perpendicular bisector. Now, so we're supposed to find the measure of EG. So because it's a perpendicular bisector, what does bisector do? Yeah, it cuts it in half. So what would this one also be?
5.
This one would also be 5. Therefore, the measure of EG would be 10. Yeah. Okay, what other questions do we have on this lesson?
28.
28.
Yeah. I did it and I thought I
You did it and you thought you got it right. Well, we're about to find out.
was more confusing was 38.
We have this big old, probably acute triangle with, that would be an altitude, yeah? Oh no, you're right. No, it doesn't have to cross the vertex. I'm thinking of a median. What is drawing on there?
One down the middle.
They're like something else.
Yeah, they added. No. There's only 3 lines.
Oh, those ones. Yeah. Okay. Yeah. That's okay. Sorry. Brain has to catch up. Do the best to kind of draw what this is. I clearly didn't draw this big triangle quite the right size, but we'll do the best we can do without other tools. So those are perpendicular bisectors. Has nothing to do with the vertex. Everything I just said a few minutes ago is a lie, by the way. Did y'all figure that out?
Yeah.
Okay, good. There was nothing in that problem that told us it was a perpendicular bisector. We just had to assume it was, which is problematic. If I wrote that problem, it would be different. Sorry, I apologize. That problem was dumb. Whoever wrote that problem was stupid, because you can't just like say stuff. Okay. All right, so let's finish drawing this less stupid problem. A. It's only slightly less, actually. Oh, no, it's not, because it says that P is the incenter, so this problem is a good problem. What is the incenter? No, what does that mean?
That's where everything is equal to it.
No.
So it's equidistant from every side.
Okay, so it is that y'all are saying properties of the incenter, but what is it?
Conjunction of all bisectors.
Yeah, all the perpendicular bisectors. It's the conjunction of them. It's where they all cross. That's the incenter. And it's important that I was telling them before, and it's on the recording, but I know since you came for part of the class, you're not going to go watch the part you missed. So there's a lot of vocabulary in this unit. You should start memorizing it now. Make your flashcards, because there's a lot, and they all sound the same. Incenter, orthocenter, circumcenter, all this stuff sounds the same, right? So start learning it, start memorizing it now. All right, so this is 13. This is 33 degrees. This is 10.9. This is 14.9. Did you figure something out? It's 28.5. Yeah, those are all the things. And for grins and giggles, we'll do all of 27 through 30, but you asked specifically for 28, is that right? Mm-hmm. Okay, so the measure of DE is what we need for that problem. So this one right here, right? So, wow, I drew that bad, but it's fine.
Is it 10.9 also the other 10.9 for BC?
Yes, it would be.
And then doesn't that make DC 10.9 because of the bisector?
No. What should we do? The fact that P is the incenter, y'all already said this, but to go back to what y'all were saying earlier, the fact that P is the incenter, what does that tell us about? What information does that give us?
They're all the same, like the 14.9.
14.9 is not the one.
Point of concurrence of the angle bisector.
Yeah, that's what I was trying to ask earlier, but I'm asking something else now. So that is what it is, but what does it tell us?
Equidistant to the sides of the
It's equidistant. So that tells us that all of these little perpendicular bisector segments are congruent. So that's congruent to that, is congruent to that, is congruent to that. Clearly I drew it stupidly, but like if I had drawn it correctly, they would all be the same, right? So we're going to need to use that information.
we could find out what.
Are there any that we know enough information about?
Could we use the Pythagorean theorem to find PB and then put it in for PD?
We definitely could. So let me kind of sketch out what you're saying. So you're looking at this triangle right here, right? We know two sides of that triangle, right? Okay, so we can find this third one. So what formula would that be? What is the Pythagorean theorem?
A squared plus B squared equals C squared.
That's true. And we need to know which one's C specifically, right? Because that's the only one that's kind of matters where you put it, right? So which one's C?
The diagonal one.
They're like all diagonal. What do you mean?
The one that's not.
Name it. Name it right. You can do it. What is it?
13, I think is what I said.
The one that doesn't have the right angle.
Yes, but what's it called? You got this.
The long
What are the two ends of it? What letters?
Oh, AP.
AP, you did it. Look at you. Segment AP. That's true. And you were also right when you were mumbling around. It is the one that's 13. All of that's correct. So 13 squared. What?
A squared plus B squared equals C squared.
Pythagorean theorem, yes.
Not Pythagoras theorem.
No, only for you and your brother and whoever taught you that. 10.9 squared plus b squared. What's 10.9 squared? Oh, excuse me. 100 and something.
This is 118.81.
118.81.
I was going to say 118, but I didn't know the 81.
B squared equals, well, 13 squared.
169.
169. Ugh. Now what?
You subtract.
Great.
118.
So b squared equals what? You have a calculator, bro. Did you forget it? Steven.
50.11.
Somebody else agree with his head?
Yeah.
Okay.
What do you think? Yeah, you didn't
You
do
printed it. But I didn't know.
All right. Now what?
It's 50.
We get rid of the
51 or 50?
Use unsquare it. You square root.
Is it 50 or 51?
It's 50.19.
Okay. We do square root. And actually, believe it or not, you were right both times. I don't know about the Ukraine, but in other parts of Europe, at least, for sure in Belgium, I'm 100% sure of that, they call that unsquare, which I wish we'd called it that here because it makes so much more sense.
They do call it the square root in Ukraine.
Do they? Yeah, maybe so. In Belgium, at least, they call it unsquare. I know that because I had a foreign exchange student from Belgium. And she was like, why do you call it that? I don't know. Your way is better in this instance. It's worth noting, and I say this pretty much every time we do this in this class, that, and it's really for next year, when you take the square root of both sides, you actually get two answers. You get plus or minus. However, we basically always throw out the negative one in this class because we're pretty much always we're finding distance, and distance is always positive. And so we absolutely value it. But this answer would be 50 plus or minus whatever it is. What is it? 20 something? 25?
7.025.
Oh yeah, duh. Yeah. Wait, are you sure? Is that right? 7 times 7 is 49. Yeah, duh. 7 point what?
0, 8, 4. It goes on a while.
Great. Yeah, it goes on forever. It doesn't repeat. So it's plus or minus that, but we throw out this one because we take the absolute value and get the positive version. Okay. So this we found out is 7.1, which is not what we're looking for yet.
So we Pythagoras theorem 14.9 and 7.9.
What are we actually looking for? DE? Yes. Yes, because I'll do that back in orange so we can color code how we got the things, right? This is also 7.1 and this is also 7.1 because all the perpendicular bisectors are congruent.
Because A, B,
Well, perpendicular bisector to the the what?
I'm just trying to remember Pythagorean theorem.
Oh yeah. Which one's C?
The long one.
AP.
Yes, but which one's on this triangle?
EP.
EP, yes. So now we're messing with this triangle, right? So 14.9 squared. And I would, when you're doing this problem, I would leave that 7.08 nonsense in your calculator and do that first with the little answer button. That way you get as exact an answer as you can get, because it's going to keep a lot more decimal places than you're going to. What's 7 point squared?
Wait, I thought A was the bottoms.
It doesn't, A and B, it doesn't matter. Commutative property, yeah. C is the only one that matters where you put it. What's that squared? It's 50.19. Just saying.
Oh, I thought you were talking about 14.
No, not that. This one. Just saying. We didn't even have to put it in our calculator. Brilliant. Now 14.9 we do. What's 14.9 squared? 222.01. So that minus 50.19 is what? 171.82, and then we take the square root. End up with B is approximately equal to plus or minus what? Did you forget your calculator too? Oh my gosh,
I woke
boys.
up at 9.
Oh my gosh. What'd you get? It's gonna be ugly, yeah?
Yeah, it's 8.474.
8.474. Are you sure that's right? Because 8 times 8 is 64, so it seems like it should be bigger. Are you sure you punched it in right? Is that what you got too?
I got 13.
That's not what I put. I didn't put it right. Sorry.
That's okay. That's good.
You put 71.92.
Yeah, I didn't put the one.
Yep.
Yeah.
Okay, so check his brain. You do it again with the 1 in it. See if you get 13 point whatever. Okay, 13.1. Plus or minus 13.1. We throw out the minus 1 because we're only interested in distance, so absolute value of that. So our answer is 13.1. Great. I think we've already answered one of these questions. Number 27, the measure of PB. We did that already. What would that be? 7.1, we did that. What's the measure of angle DAC?
33. Wait, yeah.
28.
DA.
To the top.
I know, it must mean that that's actually a line. I didn't know that. Okay, great. DAC, I would have called it PAB, but whatever. DAC is this angle, and yes, it would in fact be 33, because that's a perpendicular. No, it's not.
On the drawing.
Yeah, on the actual drawing it is.
Yeah, great. Yeah, because if it's a line, it has to be the same as that. How badly did I draw that before? Yeah, see oh no, I was looking at the wrong thing. Great. What about the last number, 30? So we're looking for the angle DEP.
Is it 28.5?
It's not. That's the difficult one. We just found, let me label this, that this is 33 degrees. And we're looking for, what did we just say? DEP, dep. DEP. So we're looking for this one. How are we going to find that? That one's trickier.
Okay, well,
I can pretty much guarantee you that there will be one like this on the test because I remember writing it.
okay, so we know that.
You can add up all the angles and they are supposed to equal 180.
Yes, all that's true. So we look at triangle AEC, so the big triangle, right? All of its angles would add up to 180 degrees. So this one plus 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 this one equals 180, right? And these are all the same. So 2 times 33 plus 2 times 28.5 plus 2 times the measure of DEP equals 180, right? How are we doing? How confused are our faces? Do we understand where this formula we just built comes from? I see that you're doing the math. You get where it came from? Good. Okay, so yeah, moving on. I'm assuming that we get it because our mouths are shut. Do we get it? Like, I'm not even awake yet. So 66 plus, he says 57. Does somebody else agree?
Yeah, because 28, 28, and then 5.
28, 28, and 5.
And 5.
28, 28, and 1.
Well, yeah, but like the point fires me for 1.
It's 57.
Okay.
Gina, how was your
You
test?
can't take the test yet. No.
Oh.
There's not a frog on it.
There's not a frog on it.
Not a frog.
Okay. Plus 2 times the measure of angle depth. Now what?
125?
Because this plus this, that sounds like too much.
Well, 15 and 2 was 16 and 7 left over is 125.
16 plus 7.
It's not 125. It's 123, sorry.
Yeah.
I was thinking 7 and 8, 76.
Did you subtract?
We do. Good job.
so it's also, yes, it is 28.5. But we didn't know that.
But we didn't know that.
It is what I wrote down, and I didn't do any of this just because I assumed, so.
But you understand how we actually did it. Yes?
Yeah.
Because it won't always match. That's just like happen to be the same. Which means, that's how I drew this problem so wrong, is because that AEC is actually isosceles. How do I know that?
Because all the angles are equal 180.
No. All triangles are, that means it's a triangle.
Base angles are the same.
Yeah, because it's got congruent base angles. So that in fact means that this is 10.9 and this is 10.9. Because it's isosceles. Look what we proved. We're so smart.
Is this 38?
This is 30.
30?
Yeah, we haven't even gotten to 30.
We did 27, 28, 29, and 30 just now.
Can we do 38?
38, I thought we went through 30.
You said plus 38 because it's a proof.
Ah, 38.
I was really mad at you for it.
Grumble, 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 grumble.
Literally, Sarah called me while she was doing laundry and I was doing homework, and I went, seriously?
Seriously.
Strangle someone.
Yeah. Strangle someone. But I wasn't there to be the one. See, that's why you do homework at home, so I stay alive. Yes. 30 was 28.5.
Oh, yeah.
But not because that other one was 28.5. We didn't know that until we did it.
Well,
You have to add up all the angles. It just happened to be the same. It wouldn't always.
Why did you decide to put these random lines in?
Was it somebody that wrote in your book?
Well, yeah, no, that, but K, D, KF, and KE are.
Oh wow! Look at this! Look at this proof. Look at that proof. What did I do? This proof is crazy. Crazy, crazy. I don't remember doing this one in class last year. I wonder if they like understood it and they were smarter than y'all. That couldn't be true because y'all's class average is higher. So
doesn't necessarily mean we're smarter.
maybe.
I mean, at least in like life skills.
Well, I think
Well-
it's because you Google classroomed everything,
I Google Classroomed everything.
so we actually have.
Oh, you're actually doing your work?
Yeah.
Yeah, that has helped. That has been a plus.
I also realized that there were several homeworks that just did not have the pictures attached, and I don't know what was up with that, so I tried to go through my photos, because knowing me, I probably just forgot to attach it. Like, I probably just went submit. And I just,
That's clearly wrong, but you know. As close as it's gonna get right there. I don't have tools.
Jacob, I say this with all the love in my heart, you look kind of like you got run over by a truck.
Not far from the truth.
Not far from the truth. You know what's funny is later in the recording, they're not going to hear what you just said. They're not going to hear what you just said.
Yeah.
And they're probably not really going to hear, they might barely hear what he just said. And then they're going to hear me say, not far from the truth, randomly. And I'm not going to explain it either. That's what you get for not being here, whoever you are.
That what?
At 9, so I didn't have time to do
Fair.
that.
No, you're fine. Like,
I was tying my shoes while I was.
you're fine.
Not
Like,
bad,
there's some
like-
people are into like, run over by a truck look. You know, it's not a bad thing, but.
I don't even know what these things are. I feel, just looking at this picture and all this stuff, I feel like this proof is going to be a pain in the butt.
You have to use those to prove that K is the inside.
I'm sure that's 100% true. I believe you wholeheartedly. That doesn't change the fact that this proof is probably a pain in the butt. Was it a pain in the butt, or was it not that big a deal? It wasn't that bad? It looks bad. Maybe it's not that bad.
I don't know if I did.
Okay. You gave it a shot. That's good. That's very much what we expect in the, especially in homework, is you to engage fully with it. That's because that's where you learn. And then you come here and learn, okay, I wasn't right, but I see where I need to correct my stuff and tweak. That way we, don't fail the test. Which we've done fairly well on so far. Of course, I haven't graded that other one yet, but I'm behind on grading. I don't remember, I think this may have been one of the classes I didn't tell any of my life story, but I went to Oklahoma on Friday afternoon and came back on Saturday and brought home parrots. And we also last week moved 2 rooms of our house, switched them furniture-wise, and are still kind of in process of doing that sort of. And so I'm a little behind, but I'll get caught up.
I'm still terrified of my grade.
You'll be fine.
Also, I looked up how to find your average grade, and it doesn't show mine on where it's supposed to be, so I guess it.
Well, you can probably calculate it.
All of them?
ABC. Given. There's a triangle ABC.
It's election night.
ABC is a triangle. I don't know why they wrote that as one of the givens. But, whatever. AD. BE is election day night something.
Who do you think's gonna win?
It's too close to call at this point, I think.
I'm going to a friend's house to watch it and watch other things. Because
I will look tomorrow.
I don't want to be with my parents while watching it.
I probably don't blame you. I don't know. I've not really heard your parents talk about politics, but I've heard the rest of your family. So.
You can guess where it came from.
Yeah.
I probably watch with my dad because that's what we always do.
Well, there you go.
Doesn't mean,
Angle.
the greatest time, but it's important.
Totally fine. I'm not going to watch. Why would I do that?
Yeah, fair. He just used to do his father and his father before.
It's fine. It's totally fine. That's what you want to do. Totally fine. I don't have any bated breaths. AB and KQ is perpendicular to BC and excuse me, KR is perpendicular to AC.
One of these gonna be on the test?
No, I don't give the anything where you are proving a theorem that you're given. Only ones where you have to use, because that's what this is. That's like if you look at the top, we're proving theorem 5.6. Theorem 5.6 says that if the end center is equidistant from all the sides. And so we're proving that K is equidistant from the sides, is what we're proving. And we can't use that theorem to prove it because that's what we are proving. So yeah, that's what's trying to happen. So we're trying to prove, yeah, so I don't give this type. It's a good, it's a fine proof to do as practice, but I don't give these kind. We're probably gonna have to use stuff from last chapter, I imagine.
Wait, is that what we're proving?
Yeah. Right?
Yeah.
KP is equal to KQ is equal to KR. I wrote it. Oh, except I wrote one of them wrong. This one's not right.
You go.
Definitely not QD. That wouldn't make any sense. And it's unless their picture is intentionally drawn way off, that's not congruent. Okay. What should we do?
So there's like a lot of extra lines in
Did I miss 2 lines? I did.
yeah.
There's 2 lines that I missed, yeah? These are one. And these are one.
Why are those lines there?
Because we need them. Because we're going to end up going for some like side angle side or something like that. I imagine. Their proof is 3 steps long, including the given. So let's see if we can beat that and do it in like 12.
How would we use side angle side? Because I thought when I did this that we were doing
They don't do that. I just figured that's what we were going to do. But what did you say?
Because I thought we were proving that the segments are congruent.
We are. So what I was guessing we were going to do is I was guessing we were going to like prove that the triangles were congruent, and then by like CPCTC the ones were congruent. But at least according to what they did, we don't have to do that, and it's even easier from that. They used a different thing. They used, instead of perpendicular bisectors, they used the other kind of bisectors. Excuse me.
Is that a thing? Parallel bisectors?
Actually, no, they did. They didn't use. Oh no, there isn't. We didn't do that. They did use. They used the other property about circumcenter. What does the circumcenter theorem say?
The circumcenter is equidistant vertices to the corners of the triangle.
Actually, that's not what we're looking for.
That it's the points between the 3 perpendiculars.
It's the angle bisector, which led me to believe that we must. Oh, there it is. I found it.
Oh, the other one.
Yeah. About angle bisectors. Yeah, see, that's what I thought we were going. Yeah, we're using the in-center stuffs. Yeah, I was right. I wasn't wrong. Great. So we're given that A, D, B, E, and C are angle bisectors. So this AD, wait. Oh, wait, what? Did I write that right?
Yeah.
Yeah, I think so.
ADD,
AD, let me read. Angle bisectors AD, BE, and CF. AD. Okay, let me label these in different colors. Okay, so I clearly didn't draw it right, but we expected that, right? AD, BE, right? Yeah. And CF. Yeah, okay, that's why some of these triangles are weird and skinny and different. Okay, here we go. I recommend this, what I just did, and I recommend you get some colored pencils. I've preached that for like forever and ever and ever. Colors are your friend when you're doing math. Colors keep you organized. Colors help you slow down. Colors are great. We like colors. I have never required it in a high school class, and I have for a long time highly recommended it because now it's so much easier to see what's happening right now, right? I was getting confused. That's not difficult. Lack of sleep, lots of emotions, and then whatever else. I've had lots. I'm tired. I'm fatigued. All the things. So it's not. So that's why I'm even more spastic and spacey than normal. In case anybody sees that on the thing, I am operating on less than optimal. And so I was confused, and y'all might have also been confused because you're newbies, right? So this is much easier to see. So great, angle bisector. So even though it comes later in the chapter, if you've been given a theorem, you can use it to prove a thing, right? Excuse me. Now, like I already said, you can't, and actually we don't know that they're perpendicular bisectors, we just know that they're perpendicular, I guess. Oh, that's why this problem is wild, because the incenter and the circumcenter in this problem are the same point. Wild. What is that crazy face? Are you thinking, are they not always that way? No, they're not always that way. Definitely not. All right, what does angle bisector tell us?
That if a point lies on the angle of an angle.
What I heard you mumble was a point lies on an angle of an angle. And so
Of an angle, then it is equidistant to the sides of the angle.
is equidistant to the sides of the angle. So the distance straight from here to here is the same as the distance. Clearly drawn. I drew this. I couldn't have drawn this worse if I tried, but it's okay. So those are all the same. So what can we write because of that? What facts can we say because of that?
On the angle of lies on the angle bisector.
Wow. I can't, like I thought I was doing kind of okay, but I couldn't have done it worse if I tried. Because if I had drawn this right, then this and this and this should be the same size.
Well, in the book, they're not the same size.
In the book, they are the same size. It's an optical illusion.
I don't know about that.
KP and KQ are congruent, are equal, is what their measures are equal. So let's start listing things. The measure of KP equals the measure of KQ. Right? Is that because BE is equidistant from these two sides. And so that's these two. I know it's drawn stupidly on the board. I apologize for my life choices.
There's like 6 too many lines there. I can't play.
It feels that way, right? Okay, so that's true. And then with this one, this is equidistant from these sides. I know it doesn't look it, but it is. So that means KQ and KR are congruent.
Okay, you lost me.
Yeah, look. I match with the book. My brain matches what's in the book. Good. Because my brain is a little bit busted right now. KQ. Let me write this down and then I'll find you again. Deal? KR. Okay. All right. This one.
Did we just prove?
No, not quite.
Oh, well, yeah.
So it's
Not quite.
distant equal.
Because we said them separately. We got to say them together.
Is it distant?
Okay.
Almost.
So just
So the first statement, the KP and KQ, come from the let's see, where am I? KP and come from this bisector. This angle bisector right here says that this equals that. That's this first one because because this bisector, if it was drawn correctly, would be equidistant from its sides. Right?
yeah.
Okay.
But at the point of concurrency or whatever.
Right. Well, yes. They're always equidistant from the sides. Like I can move that one forwards, backwards, whatever. That's just
They're at an angle.
what are at an angle. Everything's at an angle.
It's a triangle.
It's a triangle. And this is like I don't know, I'm not going to do the Facebook thing and be like, how many triangles are in this picture? You know why those are so irritating is the comment sections of those pictures.
And it would be really hard because,
Isn't it just 10 in this one?
well, no, you have to.
I don't know. I already said I'm not going to figure that out. Yeah, because it's more than that. Because there's in this one, there's 1, there's 2, there's 3, there's 4. Like there's big ones. That's why there's like a bunches. Anyway, who the heck cares? What I was saying is this means this and this are congruent, yeah? This second one we got from this bisector, this FC bisector. That tells us that this equals this. Yeah? Okay. We can also say the last one with this last bisector, yeah? That KP and KR are equal. Their measures are equal. KP equals the measure of KR.
Because of that thing.
Angle bisectors are equidistant from their sides. Angle.
The last unit.
That's good enough. Yeah. Okay. So we kind of almost we have pieces of what we need, right? We need K, PK, RK, and QK, which I wrote them backwards there and there, but that's fine. It does it correctly in the book.
So could we just say
Not substitution, but yes.
transitive?
Transitive property.
Because if A equals B
Yep.
and B equals C,
Yep.
then A equals C.
Yep. All that's accurate. So the measure of KP equals, we can write the whole statement, or we can, they just wrote like the part that we still needed, but we may as well write the whole thing. Measure of KP, the measure of KR equals the measure of KQ because of the transit property. Really, we would just write whatever one we're missing. The KP is equal to KR. So we don't really even need to write that. No, we said these. This is the A, and this is the B, and this is the B, and this is the A.
But what about the one right under it? Because of AD.
Oh yeah. We did well. Let's write the whole thing then. Transitive property sounds great. Great. Transprop. Sounds like a piece of legislation these days. Goodbye. Go away. Find somebody that loves you. Give them a hug. 20 seconds. Get your estrogen. Other chemical. Get your. What I'm looking for? What am I trying to say? No, the other one. No, not endorphins. What am I trying to say?
I don't know.
What is the love hormone, family hormone, the
Dopamine, serotonin, what are the happy ones?
oxytocin.
Oxytocin.
Get your oxytocin.